Hello, this is Lesson 10, Basic Geometry, and this is pretty basic geometry that we're going to review today. The first thing we're going to look at are some basic shapes. First, on the left-hand side, we have quadrilaterals. Quad meaning four, so they're four-sided. So we have square, rectangle, rhombus, trapezoid. The reason it's a trapezoid is because it has one set of parallel lines and the other lines are not parallel. So that's what makes the trapezoid different. And then on the right-hand side, you just have some other common polygons. You have your 5-sided pentagon, 8-sided octagon, 10-sided decagon, and hexagon is 6-sided. The next thing we're going to look at are some basic things that you will see when doing geometry problems. We're going to talk more about the triangle next, but when we're talking about angles, you want to know the basics. So this is an example of a right triangle. It's called a right triangle because it's 90 degrees. So it will either be labeled 90 degrees, or if you see this little square here in the corner, you can assume it's 90 degrees. Obtuse is greater than 90 degrees. And you know that it's greater because it opens up past that 90 degrees. So it's usually pretty obvious when it's obtuse because it opens up. And then acute is when you have an angle that's less than 90 degrees. So any angle less than this 90 is going to be acute. You have your circle, and a circle altogether is 360 degrees. So you hear that a lot. 360 degrees is all the way around. But also remember that when you draw this line through the circle, you have a straight line. A straight line is 180 degrees. So from here to here is 180 degrees. From this point to this point, it's 180 degrees. 180 plus 180 is 360. So just remember a straight line is 180 degrees. We're going to be using that in a little bit. And then, of course, we have our parallel and perpendicular lines. So just remember that parallel are lines that never cross. And when you see the arrows on both sides, that means it's a line. And think of it as going on forever. So when you have an arrow, it means that will go on forever. And when they're parallel, they will never cross. And one way to remember parallel is to see how there are two L's here, and think of those as like two lines that never cross. And then perpendicular means a line, two lines that intersect form 90-degree angles all the way around. So they're only perpendicular when they form those 90-degree angles. If you have two lines that cross but do not form 90-degree angles, those are simply intersecting. So this would not be perpendicular because it doesn't form 90-degree angles. Only when it forms those 90 degrees is it perpendicular. So now we're going to look at triangles. So triangles have three sides. Tri meaning three. It has three sides and also has three angles. Those three angles always will equal 180 degrees. So if it doesn't equal 180, it's not a triangle. Oftentimes you'll see questions that ask you to find the missing angle. Again, as long as you remember that altogether those angles add up to 180, you can find that missing angle. So this first example, you have a triangle and it identifies two angles as 55 degrees each. So how do we find that missing angle? You start with 180, subtract 55, subtract 55 again, and you'll get 70. So 70 is that missing angle. So again, you can always check your answer by saying 70 plus 55 plus 55, and you'll get 180. The example on the right, you have to find the missing angle. Now you only see 40 degrees identified, but remember that is a right triangle. It's a right triangle because it has a right angle. So you automatically know that that right angle is 90 degrees. So to find that missing angle, you would simply take 180 minus 90 minus 40, and that missing angle would be 50 degrees. So as long as you can remember that all the angles in a triangle will add up to 180, you can always solve for the missing angle. The next piece we're going to look at is the Pythagorean theorem. With the Pythagorean theorem, you want to just remember this simple formula. And again, with a lot of times on tests, you will see this formula given. So you might not have to memorize it, but again, you want to feel comfortable using it, and you want to know how to label the right triangle so that you solve for the correct side and the correct angle. So what you want to remember, too, for the Pythagorean theorem is that it only works for right triangles. You cannot use this formula for obtuse triangles or acute triangles. It's only going to work when you have this 90-degree angle. I'm just going to label parts of this. This side that's opposite the 90-degree angle is called the hypotenuse. And your formula is a squared plus b squared equals c squared. So if you're given these two lengths, in this case we have 7 feet and 6 feet. So we know two sides, but we don't know this one. Again, this is called the hypotenuse, and this is also your c squared. So if that's not on your paper, you want to make sure you write that down. These two are your a and b. It honestly doesn't really matter which one is a or which one is b, as long as you pick one and stick with it. But this will always be c, because the hypotenuse is the side opposite the right triangle. So this is always your c squared. And that matters when you're filling in these numbers. So if I want to find out what this length is here, I want to plug this 7 and the 6 in for a and b. So I'm going to call this one a, this one b. So my a squared would be 7 squared. My b squared is going to be 6 squared. And that will equal c squared. Again, c is what we're solving for. We're trying to find the length of this hypotenuse. These are pretty basic multiplication, but if you're not sure, you can always use your calculator. Remember that squared means the number multiplied by itself. So 7 squared is 7 times 7. 6 squared is 6 times 6. So don't get confused with just multiplication. It's not 6 times 6. I'm sorry, it's not 6 times 2, it's 6 times 6. This is 6 squared. This is 7 squared. So 7 times 7 is 49. 6 times 6 is 36. And again, we're trying to find what our c squared is. So when I add 49 and 36, I get 85. That's my c squared. But you're not done here, because 85 is not your answer, because here you have a squared. You want to find out what this is without the square, because notice how this isn't 7 squared here. It's just 7. This is the formula we use. So in order to find out what this is, we have to take the square root of it. And that looks like this. So the c is actually going to equal the square root of 85. Now, thankfully for most of these problems, you're going to be able to use a calculator. And even on the basic calculator, you'll be able to use the square root function. So you would just type in square root 85. And the square root of 85 is 9.2195. So usually it's not going to always end up to be just a whole number. Look for your question to find out if they want you to round. So do they want you to round to the nearest whole number, nearest 10th or 100th? It just depends. We're going to simply just round this to the nearest whole number. So because it's only a 2, this will just become 9. So we know that the length of this side is about 9 feet, a little bit over. So again, think about it reasonably. If this is 7, this is 6, and if this turns out to be 9, that sounds about right. If you had left it at 85. Say you forgot to take the square root. That would make no sense. How could these two be 6 and 7 feet, but this one's going to be 85? That wouldn't make sense. So always double check your answer so that it seems reasonable. Again, the square root of something just means what number times itself will give you this. So we talked about the square root of 7. I'm sorry, the square of 7, for example. The 7 squared would be 7 times 7, which is 49. What if I did the opposite and I said, what is the square root of 49? Again, if you try that on your calculator, the square root of 49 is simply 7. So you're just doing the opposite here. If you square something, you multiply it by itself. To take the square root of, you're trying to figure out what number do you multiply by itself to get here. So we have 7 feet, 6 feet, and then 9 feet. Again, you want to make sure you remember you're only using this for a right triangle. Let's look at the same problem, but instead of looking for the hypotenuse, we're going to look for a different side. Because sometimes you'll see questions where they'll give you the hypotenuse, but then you have to find one of these. So, oops, this is 10 feet. This is what we don't know. So in this problem, this is our A, this is our B. We'll just call it B, actually. So this is our side B. We don't know what it is. And then our side C is going to be 10 feet. But we're going to use the same formula. A squared plus B squared equals C squared. We know our A is 7. We don't know what B is. And then we know that C squared is, we know C is 10, so what's 10 times 10? 100. And actually, so this should be 49. We'll leave this as 10 times 10, or 10 squared. So now we want to get this B squared by itself. So because we have a positive 49, we're going to subtract 49 from both sides. B squared, 100 minus 49 is 51. But remember, this can't be 51, that's way too big. It's going to be a number that's somewhere around 7 or 10. We want to find the square root of 51. And the square root of 51 is 7.1414, and it goes on. So again, it's not a whole number, but we can round it to the nearest whole, which would be 7. So it's not exact, it would be 7.14, but we know that, again, that makes sense because the numbers are all close to each other. They're not too far apart. Okay, the next section we're going to talk about, we're still dealing with angles. We are going to talk about corresponding angles, complementary angles, and supplementary angles. Corresponding angles are angles in the same position relative to the intersecting line. So they're congruent, which means they are equal in measure. So congruent meaning they're equal in measure. So on this example, we have two parallel lines. So these two lines are parallel, right? Because they never cross. They'll go on forever without crossing. And then you see one line that intersects with those two parallel lines. Again, it doesn't form any 90-degree angles, so there's nothing perpendicular here. It's just a line intersecting with a set of parallel lines. And then looking back at the slide, you have your complementary angles, which are two angles with a sum of 90. So those two angles together are going to equal 90 degrees. And then supplementary, you have angles that will add up to be 180. So supplementary are two angles that add up to 180. So if we look back at our chart, some of this I have filled in. So you'll see on your PowerPoint that what I have here is the same thing that you have on your PowerPoint, but we are going to fill in some of these answers and talk about what these terms mean. So when they talk about corresponding angles, again, this happens when you have a set of parallel lines and a line that intersects. Because I have 40 degrees here, this angle corresponds. It's congruent because this line crosses through that line the same. And again, it's because they're parallel. If these were not parallel, we wouldn't be talking about this. So if this one's 40, this angle is also 40 degrees. And you can see they look the same. If this angle is 140, this angle is 140. So the point of this is sometimes you will have a picture and they'll only give you some of the angles and you have to figure out what the rest of them are. But if you know this concept of a line intersecting parallel lines, you can fill this in. So this angle and this angle are corresponding. This 40 degrees and this 40 degrees are corresponding. Another concept is the vertical lines. So that just means when you have this same intersecting line that the two lines opposite, or I'm sorry, the two angles opposite are equal. So if this angle's 40, this angle will be 40. Because this one's 140, this angle is also 140. Because DEZ is 40, this angle is 40. There are different ways to look at this too, and different ways to answer these questions and to fill in the angles. So for example, this is a straight line. Remember, a straight line is 180 degrees. So even if they only told us that this one was 140, I would know right away that this one is 40, because 140 and 40 equal 180, and this is clearly a straight line. So just knowing that a line is 180 degrees can also help you answer for missing angles. Also notice the way the angles are named. So when you see this sign, that means it's naming an angle. So angle ABY would be ABY. So it's this 140 here. So it's 140 degrees. So the middle, as long as that middle letter is the middle point, so ABY. Angle YBC, so YBC. Now we're looking at this angle here. That's 40 degrees. Angle YEF. So here's our Y. E is here, and here is point F. So we're going from YEF. So this is the angle we're talking about because it's the letter in the middle. That would be 40 degrees. The next one we're going to talk about is complementary angles. So again, complementary, that's when two angles are going to add up to 90 degrees. So here we have a right triangle. And remember, a right triangle is 90 degrees. So this angle, this whole thing is 90 degrees. But here I've drawn a line to form another angle. This angle is 40 degrees. So if altogether it's 90 and this one's 40, how much is this angle? How many degrees? So you simply take 90 minus 40, and that missing angle is 50 degrees. That is the example of complementary. these two are complementary because together they form 90 degrees. Supplementary angles together form 180 degrees. So again, it's two angles together that are going to form 180. So remember, 180 is a straight line. So 140 degrees and 40, that equals 180. So YBA, so angle YBA and ABE, are going to equal 180. Those would be supplementary because YBA and ABE form 180. So again, just knowing even one of these angles means that you can fill in the rest. You can solve for the other missing angles. Also remember the difference between obtuse and acute. So obtuse greater than 90, so this would be an obtuse angle, and this would be an acute angle because it's less than 90. So that is all we have for basic geometry. We will see you in the next lesson.